Hi everybody. Now we will be discussing today on diffusional flux. Now what do you mean by flux? Flux is nothing but, if it is diffusional flux, then flux is nothing but amount of materials, maybe number of atoms or maybe mass, which is diffusing through an unit area per unit time. If this is number of atoms diffusing through unit area per unit time, then the unit should be atoms per meter square second, or if this is mass of atoms, that means if you multiply molecular weight with the number of atoms, then that will give you the mass of atoms or mass of that particular material which is diffusing through unit area per unit time will give you flux again, and the SI unit for this time will be kg per meter square second. Now how would you define the area? From the picture you can see, from the picture this is the up front, that means if this is a packaging film, it may be a packaging film, it may be a metal plate, it may be a concrete slab, it may be wall of the room, it may be aluminum foil. So generally for industrial problems we generally come across or generally experience diffusion through either metal plates or different packaging material, through which we have to calculate out the diffusional rate, and hence we can calculate the shelf life of the material inside the packaging material, water vapor transmission rate, gas transmission rate, and other things in other cases. So if the thickness of the metal plate or the packaging film is say L or D, this is the thickness across which the diffusion is happening. So if this surface is the front surface, upfront surface or the upstream surface for diffusion, that means diffusion is happening from the left hand side direction to the right hand side direction. That means from this direction to this direction, as it is shown by the arrow sign, and the molecule which is diffusing, if it is a gas, and if the positions are termed as, if this position is termed as A position and this position is termed as B position, then diffusion is happening from A position to B position. If the pressure at position A is PA, and if the partial pressure of the gas is PB at position B, then for diffusion to happen, PA must be greater than PB, and the PA minus PB must be constant. So across this constant pressure difference, a molecule or gas molecule is diffusing through this particular slab or plate. So if this is so, then, and the direction of the flow is as mentioned in the, or as shown in the picture, then the area through which the flux should be calculated is the area which is perpendicular to the direction of the flow or the flux. So flux is J, so direction is the x-axis direction. So to this direction, perpendicular direction is the y-axis direction. That means the area of the slab or metal plate is exactly perpendicular to the direction of flow. That means the total area of the surface through which this diffusion process is happening should be taken into consideration for calculating flux. So if this is A, total area, perpendicular area or cross sectional area perpendicular to the direction of the flow is capital A, then flux must be J equal to, assume total mass diffused during a span of time of t, and A is the flow area, perpendicular flow area, then J must be m divided by A, capital A, into T. In terms of differential manner, you can also say this is J is nothing but dm by dt into 1 by A. So this will give you total flux. For today's class, we have come across with the definition of flux. Then we will be discussing how this flux can be related with the driving force in the next class. Thank you.